Hello everyone, welcome to my YouTube channel TechSpot. This is me Harish Gaupale. So basically in this video we are going to discuss about a design implementation of 4:1 MUX. But before that, in my previous video I have explained about the multiplexer and design implementation of 2:1 multiplexer. So before watching this video, go and watch that video so that you can easily understand the functionality of multiplexer. Now if I talk about functionality of 4:1 multiplexer, so it has 4 inputs. It can be A, B, C and D, and it has 2 select line. It can be S0, S1, and it has one output, that is Y out. So based on the select line, our inputs, that is A, B, C and D, will be routed to the output Y out. Okay, now let's jump for the design implementation of 4:1 multiplexer by using Verilog procedural blocks, that is always @ and always *, and by using SystemVerilog procedural block, that is always comp. Let's move to the screen. So you can see my screen. I have already written a code for the design implementation of 4:1 multiplexer by using Verilog procedural blocks such as always *. Okay, so first we'll understand this code line by line, and for the verification of this 4:1 MUX, I have simply write a TB code also. So we'll understand that code also. After that we'll see the schematic, and then after that we'll see the waveform. Okay, so if I talk about code, so you can see my module name is MUX 4:1, and then I'm having 4 inputs of size 4 bit, that is A, B, C and D, and select line, that is 2 bit, and the output of 4 bit. Okay, now inside the procedural block always *, I have used a case statement. I have already explained about the selection statement, and case statement is a part of selection statement in my previous video. If you don't know about the case statement, so go and watch that video. Okay, if I talk about the functionality of this case statement, so here I am having total 4 cases: 0, case 0, case 1, case 2, case 3. If select in is 0, then case 0 will be matched, so input A will be routed to the output Y out. If select in is 1, then case 2, the case 2 will be matched and B will be routed to the output Y out. Similarly with C and D. Okay, now if I go for the TB code, so you can see my TB, my module name is TB for 4:1 MUX. Same inputs of 4 bit, that is A, B, C, D, a select line of 2 bit, and output of 4 bit. Okay, now this is the instantiation. MUX 4:1 is the module name, design module name. Okay, and instance 2 is the instance name, then the instance of all the signals, input and output. Okay, then inside the initial begin, I have assigned some values to the inputs: input A, B, C, D and select line. Okay, now I'll click on the schematic. As I already click on the open elaborated design, so you can see the schematic. My select in is 2 bit. Now based on 2 bit, 4 combinations will be created, and we are having 4 inputs A, B, C, D. So if select line is 0, then input A will be routed to the output Y out. If select line is 1, then B will be routed to the output Y out. If select line is 2, then C will be routed to the output Y out. Okay, now as I already click on this run button, so I will directly click on this relaunch simulation. So then it will give me the waveform. Okay, just wait for a minute. It is giving the waveform only. Yeah, here you can see the untitled and the waveform. Let's remove this. Yes, you can see when my select in is 0, at that time the value of A, that is 1, is routed to the output Y out. Okay, when select line is 1, then the input B, that is value 6, is routed to the output Y out. When select line is 2, then the input C, that is B, is routed to the output Y out. When select line is 3, that means the input value of D, that is how much 0, is routed to the output Y out. Now similarly I have implemented the 4:1 mux by using system Verilog procedural blocks. That is always pump. The same code is there, only the procedural block is very different. Here I have used always pump, begin end, and there I have used in Verilog I have used always add the rate star. Here you can use always add the rate and sensitivity list. Instead of adding star, you can add all the input and output signals. Okay, now we'll jump to here only. So the same code I have used case statement only, as when case will be matched, if select in is 0, then case 1 will be matched, so A will be routed to the output Y out. When select in is 1, then case 2 will be matched, means B will be routed to the output Y out. Okay, for this design code also I have written simple TB code, that is TB for 4:1 mux, then input signals, output signals. Okay, as the instance of this 4:1 mux design. Okay, and then inside the initial begin I have assigned some of the values. Okay, here also I will, if I click on the schematic, then it will also give me the same schematic as we saw in the Verilog 4:1 mux. Okay, same schematic. And if I click on this run simulation, okay, I already have run this, so I'll click on this untitled file. That is already the waveform I got. So if you see the waveform, 1 minute. Yeah, so you can see when selecting is 0, so the value of A, that is B, is routed to the output Y out. Okay, when selecting is 1, then the value of B, that is 3, is routed to the output Y out. And when selecting is 2, the value of C, that is 0, is routed to the output Y out. And when selecting is 3, the value of D, that is 7, is routed to the output Y out. Okay, so this is how we can implement a 4:1 mux by using a Verilog procedural block and system Verilog procedural block. So in this video, I have explained about the 4:1 mux and the design implementation of 4:1 mux. Here I will stop the video. If you are watching this video, then please click on the like button, and if you are new to this YouTube channel, then please subscribe to my YouTube channel. Thank you so much.